Hello and welcome. This is Bijan Hushiar. Our objective is to configure EIGRP for both IPv4 and IPv6 in this internetwork. Therefore, we need to configure all the devices with both IPv4 addresses and IPv6 addressing. A unique IPv4 address and a unique IPv6 network address is set aside per each of the four networks that you see in the topology diagram. First, we're going to go ahead and configure router 1, access privilege mode, then global configuration mode. Then we are going to enable IPv6 routing with this command, IPv6 unicast routing. Then we start configuring interfaces. First, we configure interface G01 as a dual stack type of interface. Interface G01, IP address 192.168.254.255.255.255.0. That is the IPv4 address that we assigned to G01. Now we want to assign a globally unique IPv6 address to it. IPv6 address 2001 colon D1 double colon 1/164. Then we are going to assign a link local address to it that can be used as a default gateway by devices in this network. IPv6 address FE80 double colon 1 keyword link dash local. Then we are going to assign autoconfig to it. We are going to configure G01 with autoconfig. That way, the router is going to send prefix and prefix length plus the link local address of G01 to these devices to be used by them to configure themselves with IPv6 addressing. That command is IPv6 address autoconfig. Then we have to turn the interface on, no, shut. We exit to global configuration mode and we start configuring G00 of it with the 123.1 255.255.255.0, which is the first IP address of this network, IPv4 address of that network, and we start configuring the interface with globally unique IPv6 address, link local address also. IPv6 address 2001 colon D123 double colon 1/64/60. Then a link local address, IPv6 address FE80 double colon 1 link local. I have already used the same address on G01. It doesn't matter. Link local addresses must be unique per network. They can be repeated in an internetwork, once in this network, another time in that network, and so on and so forth. So IPv6 address FE80:1 link local. That's it. I have to turn the interface on, no shot. Router 1 is done. Let's go to router 2. We access command line interface. Enable conf to access global configuration mode. Enable IPv6 routing, IPv6 unicast dash routing. Then access G01 of it, assign the IPv4 address of 192.168.2.254 with the subnet mask of 255.255.255.0. Assign the first IPv6 address as the global unique address to it. IPv6 address 2001 colon D2 double colon we assign the second one. Second one or first one, doesn't matter. We assign the first one with /64. I assign a link local address, IPv6 address FE80:2 link dash local, and then autoconfig IPv6 address autoconfig, then turn it on, no shot. Exit interface G00, IP address of 123.123.123.2, 255.255.255.0, IPv6 address 2001 colon D123 double colon 2, because we have already used one on G001 of the router 1. They are in the same network. A link local address, IPv6 address of FE80 double colon 2 link local. I cannot use FE80 double colon 1 because I've already used that on G00 of router 1. G00 of router 1 and router 2 are in the same network. No shots. This router is done. Let's go to router 3. Label. To go to global configuration mode. Activate IPv6 routing with IPv6 unicast dash routing. Access interface G01, IP address of 192.168.3.254, 255.255.255.0, IPv6 address of 2001 colon D3 double colon 1/64, a link local address of IPv6 address FE80 3 link local I forgot the K, and then autoconfig IPv6 address autoconfig, and then no shot. Exit interface G00 IP address of 123.123.123.3 255.255.255.0 IPv6 address of 2001 D123:3/64 IPv6 address link local of FE80:3 link dash local no shot. Routers are configured as dual stack. Let's examine to see if our configuration is done correctly. We show IP interface brief. This displays the IPv4 addressing that we have configured on router 1. If we want to see the IP addressing that we have configured as far as IPv6 is concerned, the command is show IPv6 interface brief. Since I'm not in privilege mode, I have to spell a do in front of it. As you notice, G00 has this link local address, this globally unique address. G01 has the same link local address, a different prefix ID for G01, which is correct. Let's go ahead and examine router 3, G00 of it, G01 of it as far as the IPv4 addressing concerned. As far as IPv6, we change that to IPv6, and you'll notice that G00 of it has link local address of 3, globally unique IPv6 address. G01 has same link local address because these two interfaces are in two different networks. Doesn't matter. It has a unique globally IPv6 address. And we can do the same thing on router 2 as well to show IPv6 interface brief. It displays globally unique and link local address of G00 and G01. I want to perform the same thing for IPv4. All you have to do is delete that v6, and these are the IPv4 addresses that we have configured on router. This system is configured as a dual stack. Let's take a look at the PCs. PC1A has a unique IPv4 address. It is using the IPv4 address of G01 of router 1 as its default gateway, and it has received prefix length, and default gateway, and it has come up with its own interface ID. PC1B, correct IPv4 addressing, correct IPv6 addressing. Let's check PC2, a different network than PC1A and PC1B, and correct prefix length, and it came up with its own interface ID. It also received the default gateway from the router. Let's check the server. Same thing in here. Seems to be correct. Let's check server 3. Static IPv4 address and dynamic IPv6 addressing by receiving prefix length, and default gateway from G01 of router 3. It came up with its own interface ID based on its own MAC address and inserting FFFE in the middle. So this internet network is configured with dual stack. And let's examine the routing table of the router 1. Show IP route. As you notice, the IPv4 routing table of the router 1 has only 2 routes in it, 2 connected networks. Router 1 is aware of this network and that network. It's not aware of these 2 remote networks connected to G01 of router 3 and router 2. Let's examine its IPv6 routing table. It's show IPv6 route. Again, it is aware of 1 and 2 attached or connected IPv6 networks, which are this network and this network. It's not aware of the networks attached to G01 of router 3 and router 2. Same is true for the other routers. They are aware of the attached network, but they are not aware of the remote networks. In order to make them aware of the remote networks, we have to configure EIGRP. Since we have the stack in here, we have to configure EIGRP twice, once for IPv4 and second for IPv6. Let's go to router 1, access global configuration mode. Let's go ahead and enable EIGRP with this command, router EIGRP. And then after that, we have to place a number. That number is called autonomous system number, AS. It has to be the same for all 3 routers. We are going to use number 4. Reflecting IPv4, you don't have to use 4. Any number between 1 to 65,000 can be used. If you go to internet with it, you have to get it from internet authorities. For local area network, you can select any number that you want. I just picked 4 to reflect that this is for IPv4 addressing. Then after that, I have to add the networks that are going to be advertised by this instance of EIGRP on router 1. The 2 networks are this network and that network, because those are the ones that are attached to router 1. And the keyword is network. And then after that, the net ID 192.168.1.0, followed by wildcard mask. Wildcard mask of a class C network address is 0.0.0.255, which tells the system if a packet, this command will tell the system, if you receive a packet that has, because of this 0, exactly the same first octet, because of the second 0, exactly the same second octet, and because of this third 0, exactly the same third octet, and because of this 255, ignore whatever value they have on fourth octet, just go ahead and route it. That's for one of the attached networks. There's another attached network, network 123.123.123.0 with the same wildcard mask. And then, since all these networks are not contiguous, I prefer to have this command added also. No auto dash summary. Okay. EIGRP version 2 or for IPv4 is configured on router 1. Let's go ahead and configure it on router 2. I go to global configuration mode and we say router EIGRP and autonomous number. This autonomous number must match router 1's autonomous number so they can exchange their routing table. So we have to use 4 in here. Then you have to add the networks that are attached to router 2. Network 192.168.2.0 with the wildcard mask of 3 zeros and a 255. There is another network that is attached to this router, and that is network 123.123.123.0 and with this wildcard mask 3 zeros and a 255. This network is attached to all 3 routers because all 3 routers through their G00 interface are connected to the same switch. It's the same network. And then we perform no auto summary as well. It's a safe command to do no auto summary. As you noticed, the EIGRP started working between these two routers because they have this shared network. Let's go ahead and configure the router 3, exit to global configuration mode, router EIGRP, the same autonomous number, network 192.168.3.0 with the wildcard mask of 3 zeros and a 255, and the same network that is attached to all 3 routers with the wildcard mask of 0.0.0.255 and a no auto summary. All right. EIGRP is configured in this network. Let's examine the routing tables. To show IP route, 2 routes are added. They are obtained using EIGRP. EIGRP is a routing protocol created by Cisco. When you're using Cisco routers, you can configure this. Between Cisco and non-Cisco routers, be careful, it may not work. Cisco says it would work, but be careful. So these 2 routes obtained because routers exchange their routing protocols and they become aware of the remote networks that way. Let's see if router 2 obtained any routes. To show IP route, yes, it obtained a path to network 1 and a route or a path to network 3 using EIGRP. Let's see if router 3 found any path to these 2 networks. To show IP route, yes, EIGRP provided a path or a route to network 192.168.1.0 and a route to reach network 192.168.2.0 0. Now, let's go ahead and test end-to-end connectivity. The IPv4 address of this server is 192.168.3.1. Let's see if we can access it from PC1A, ping 192.168.3.1, and if replies are coming back, we have end-to-end connectivity. Reply is coming back. Very good. Let's see if we can reach it from PC1B, ping 192.168.3.1. Yes, replies are coming back. So there is connectivity between those two networks. See if there is connectivity between these two networks. This PC is 192.168.2.2. Let's see if we can ping that one. 2.2. If replies are coming back, there is connectivity. Replies are coming back. So there is connectivity between these networks. How about these two networks? Let's go ahead and test that. Ping 192.168.3.1, which is the IPv4 address of the server 3. Replies are coming back. There is end-to-end connectivity. This internetwork is converged as far as EIGRP for IPv4 is concerned, as far as EIGRP version 2 is concerned. All the three routers have the same routes to each and every network that exists in this internet. But that's how you configure EIGRP for IPv4, something that is also referred to as EIGRP version 2. Now we're going to configure EIGRP version 3 for IPv6. So I'm going to go to router mode, exit to global configuration mode, enable EIGRP version 3 on it with this command, IPv6 router EIGRP. I'm going to use autonomous number 6 to show to you that I'm working with IPv6, and I could use any number between 1 through 65,000 as far as as long as they are not being used. So I enabled the EIGRP for IPv6 on it. Then I have to configure router ID using this command, EIGRP router-ID, and then an IPv4 address as router ID. I'm going to use 1.1.1.1, reflecting it is router 1. Then I have to perform no shot, otherwise it wouldn't work. No shot. So EIGRP for IPv6 is configured and enabled on this one. Then I have to place interfaces. I have to tell interfaces that they are part of this EIGRP. So I go to interface G00, and the command is IPv6 EIGRP1. You are part of this I'm sorry, 6, not 1. So I'm going to nullify this command, no, and then I'm going to change it to 6. It's part of EIGRP with autonomous number 6. That's what we configured. We did not configure that one. So this command, I was too fast. I nullified it like that, and then I have to remove that no from it. Otherwise, I haven't put it in. Yeah, now it is done correctly. So this was extra I pressed enter too fast. This was wrong because I configured autonomous number 6. Where did I get that one? It was just a mistake. This is the correct one. So I'm going to copy it because I need it a lot. So I'm going to exit. This was interface G00. I access interface G01 and perform the same command. You are part of EIGRP, autonomous number 6. The network attached to you will be advertised by EIGRP for IPv6 packets that are to reach to the network that is attached. You will go through you being G01. So router 1 is done. Let's go to router 2. On router 2, I have to be in global configuration mode first. Then I have to enable EIGRP 6. This 6 must be exactly the same number that we used on router 1. I have to configure a router ID on it. EIGRP router-ID, a unique IPv4 address. I prefer 2.2.2.2 to be consistent with this one. And then no shots. And then exit and work with its interfaces. There are two interfaces, G00. Both of them are part of EIGRP autonomous number 6. Exit, interface G01, same command. That's it. This router is configured as well. Let me go ahead and configure router 3. I'll go to the global configuration mode, IPv6 router, EIGRP6, EIGRP router-ID 3.3.3.3, no shot. Then I have to work with the interfaces, interface G00, same command. You are part of EIGRP autonomous number 6, exit, interface G01, and perform the same command, and EIGRP momentarily will be converged. The routers will be converged using EIGRP for IPv6, and their IPv6 routing protocol should reflect obtaining 2 routes to 2 remote networks. Let's examine routing table of router 1 to show IPv6 route. There you go. One route. Second route obtained from EIGRP for IPv6. Now router 1 is aware of the 2 remote networks. Let's examine router 2's routing table to show IPv6 route. It is also become aware of 2 remote networks through EIGRP version 3 or EIGRP for IPv6. Let's see if router 3 obtained any routes to show IPv6 route. Yes, it did, and these are the 2 routes obtained from exchanging the routing table with the other 2 routers using EIGRP version 3 or EIGRP for IPv6. Now, I say that EIGRP version 6 is configured correctly right now. The only thing is that I want to verify to see if there is end-to-end connectivity. I go to command prompt of server 3 and perform ipconfig IPv6 config IPv6 config /. I do that to be able to copy that globally unique address because it's long. I don't want to make a mistake in typing or forget it. Then I go to this PC, see if I can ping that IPv6 address. If I can, there is end-to-end connectivity between this network and that network. As you notice, replies came back. Let me test it on this other PC. Ping, paste it. Replies are coming back. Let me test it from PC2. Ping, the same address. Here you go. So there is end-to-end connectivity between this network, that network, between this network and that network. How about these two networks? Let me just go ahead and do the same thing in here. IPv6 config /o to copy its globally unique IPv6 address and see if I can ping it from other PCs in network attached to G01 of the router 1. Ping. I can. Let me try it on PC1B also to make sure everything is done properly. Ping. There you go. Therefore, it verifies there is connectivity between these two networks, and we've already verified connectivity between those two networks and these two networks, and it is possible because we configured EIGRP version 3 for IPv6 addresses.
Thank you for watching. If you liked the video and you found it informative, please don't forget to recommend it to others who may be interested. Thank you.